We're doing polar coordinates now, so different thing.
Different.
Yeah.
So when I'm done with their stuff, I'll jump to you and we'll do polar coordinates. I forgot you were
I
doing.
have a practice assignment I'm doing right now.
Okay,
I don't
perfect.
know. This is a review too.
Yeah, you got that coming up, right? Test or quiz or something or final or something.
Oh, good. I can do those things.
Yeah, go formatives, yeah.
Yeah, I hated those things for chemistry. The pain to write all your work.
Right. and
So
we
I'm like
didn't-
shorthanded, and she, like in half the time, she, not go all the time, but half the time she would take off what she said and she would not my
We didn't even do right. It's just like terrible all around.
All right, page 1, expand or simplify.
expand and simplify.
Expand and simplify. So expansion, do you guys remember? Do you have it memorized? This is equal to, someone want to tell me? Sine, was it sine X cosine? Or sine A cosine B, right? And then minus the sign stays the same?
This is one of the identities we don't have to have memorized.
Okay, so if you don't need to have it memorized, just make sure that you know where to find it.
Yeah,
In your
just so
packet.
she'll have it on the top of the test.
Okay,
The only ones that are like that. The ones we learned in the beginning.
Yeah, that we already have been quizzed on.
did I do this right? Check it for me, guys. Did I do that right?
Let's see, one is sine A, cosine A, and cosine B minus sine B, cosine A.
Is that right?
Wait, is it doubling or singular?
It's the sum difference. See how it's a difference?
Oh, yeah.
Does he want to come in? If he's got pre-calc, tell him to join us.
I have friends who go to pre-cal.
Not him.
Yeah.
You can let them know if they want, if they need help, they can come in. Just all happy.
So it's sine A, cosine B minus sine B, cosine A.
Did I do it right?
Yes.
Look right?
Yeah, looks right.
All right, so what's the cosine? Let's grab our unit circle.
The cosine for just x.
Here, I'm gonna put this on here so you guys can all borrow it whenever you need it. There's my
Wait, mine says sine A, cosine B, cosine A.
cosine A sine B. It's the same thing. I think I put sine B cosine A. The order's mixed up in the one I think.
Yeah, it's sine
My
B,
God.
cosine A, and then on another one, it's cosine A sine B.
It's the same thing if you, right,
Yeah,
because it's
multiplications.
multiply. Got it? Makes sense, Izzy?
Yeah.
So what was this equal? So what's the cosine of pi over 2? Cosine of, where's pi over 2 at? Look for your unit circle. Pi over 2 is up here.
Oh, 90.
Yeah, it's 90. So what's the cosine of that?
Pi over here.
It's 0, right?
Yeah.
And what's the sine of that? 1. So this is 0 and this is 1, which means this whole thing goes away, right? Because 0 times sine of x is still 0. And this just becomes negative cosine x. Good?
That's all they want.
Yep. That's all they want. Now for this next one, this is a great question. Who was I just dealing with this the other day on? I feel like one of you guys, was it Michael? Were we looking at this?
This one?
The triple angle?
Yeah.
So here, I'm going to show you a really cool shortcut. Ready for this next one? Izzy, look at this. See that 3x there?
Yeah.
That means the period is what? You remember how this affects the period? That's right. I've done it for like 3 people. The period is equal to what? Normally it's 2 pi, but in this case it's 2 pi divided by b, right? Remember how that's the period?
Oh,
Remember how the period is always 2 pi over b, and what's b in this case?
Oh, you did this for me also.
Mhm. The period is actually 2 pi over b, right? So watch. Normally between 0 and 2 pi, so here's 2 pi, your cosine graph normally would look like this. It would start up here, it would end up here, and it would bottom out down here, and your cosine graph would look like this normally, because the period is normally 2 pi, right? Are we good with that? But now, by having a 3 here, that means that I have 3 of these shapes where there normally would have been 1. In other words, the period is now, like if I break this right here into thirds, so like here and here, something like that, right? There and there. See how I've got 3 equal, well, that's not quite equal. See, I have 3 roughly equal segments. 1, 2, 3. Do you see that? I'm going to have this shape 3 times. That's what that means to have a 3 right here. It means that I've got 3, the period is a third of what it normally would have been. So instead of 2 pi, it's 2 pi over 3, which means I've got 3 of these. So if I normally would have, how many places do I normally, how many 1/2 do I normally have in my cosine graph? I normally have 2 because 1/2 is right here. The yellow line, it represents 1/2, right?
Yeah, but you're gonna have 6 now.
I normally would have 2, but because I divided it by 3, that means I've got 3 times as many as I would normally have. So you don't have to explain it all that way, but that's how you know it's going to be 3 times as many as you would expect it to be if that 3 is there. What if there was a 1/2 there? What if it was 1/2 x? You'd have half as many as you'd expect, which would be what? Normally you'd have 2 solutions, right? Did you get that? I'm trying to read your face and I can't see it. You would normally have 2, right? You would normally have 1, or look at the blue. 1, 2, that's normally how many you would have. But if there was a 1/2 here instead of a 3, that would mean that your period is twice as big. Because remember, you divide by b. So dividing by 1/2 means multiplying by 2. So your period is 4 pi instead of 2 pi. So your graph would be extended out like this. Get what I'm saying? Get what I'm saying? So this number right here tells you what you have to multiply the number of solutions that you would expect in that range. But you have to be kind of careful, because if it's a tangent graph, they might not say from 0 to 2 pi. They may say from 0 to pi. So just make sure you look at it carefully. Don't just assume all automatic, 3, I have to multiply by 2, it's going to be 6. Got what I'm saying? Because they might have said, how many solutions are there on the interval from 0 to pi? They might try to trick you like that. Well, now how many solutions would there be from 0 to pi? There would be only 1 solution normally. So now there would be 3 if you had a 3 here. Or if this was a 1/2, there'd be 0 potentially. 0 or 1, kind of depends.
We'll put a line right around that. That would be 0.
Okay, so for this one, it says rewrite the following. Basically, you just have to recognize what kind of problem is this, right? You're just going to recognize what kind of problem. Hey, what's up? I'm good. Mr. Dwyer, what's your name?
Danny.
Dan, good to meet you, man. So what's this going to be right here? What does that look like? Does it look like anything on your cheat sheet? On your formula sheet? Hey, wow, we got everybody in here today.
Yes, sir. This is Chase.
What's up, Chase? I'm Mr. Dwyer. Good to meet you, man. What is this right here? What's this going to be? Do you recognize the pattern?
That's very similar to the cosine of a.
Do you guys have that little cheat sheet? You wanna take a picture of that, Mitchell, and throw it on there? Hey, Kayla, you create a different Jamboard?
Oh, yeah. I can do that.
Yeah, because your questions, they haven't even done those yet. So they're gonna, yeah.
Can I ask you a question real quick?
Yeah.
So whenever I'm trying to like solve for these,
Mhm.
whenever this is square root, I always just don't know what to do. Like what
We're gonna get to one soon.
oh, okay.
You wanna give Mitchell your email. Mitchell back there, give him your email and he'll share this Jamboard with you. And then you can just paste, actually, I'm sure these guys have put some of those on there.
I mean, I can just
Yeah.
watch.
Do you see it?
Yeah, it's on
Yeah. We'll get to it.
3.
I'm sure we'll get to it. So how would I rewrite this? Anyone have an idea? Izzy, do you know how to do it? This one? No? Do you have your cheat
Oh,
sheet?
wait, I know how to do that.
Yeah, how do you do it?
Cosine 15 minus.
Oh, there it is. Thank you, whoever put that on there.
Let's see if it.
No, I already did this.
Why did that turn out like that?
There we go. That's good now.
Alright, there we go.
You see that? So which one is it? It's cos plus sine. Do you see it right here? Cos plus, plus sine. You see it? So it's cos A minus cos A minus B. Y'all see that?
Yeah.
Get it?
Oh, I just.
So it's gonna be cos A minus B, which means what? Cosine of what? What's 15 minus 20? -5 degrees. Got it? You guys can let him know what your email is and he'll add you to this Jamboard. That way you got a copy of this, you can see it. Or Micah, yeah, I mean, if you want it later, you can. It's also streaming on YouTube right now. So you can watch it later, get it from Micah, he's got it. How about this one right here to the right? What's that look like? Does it look familiar? Do you see it over here? Do you see the double angle identities? It looks kind of like that one, doesn't it?
Hey, Mr. Dwyer.
Mhm.
It's just black screen on YouTube.
Really?
Yeah.
Oh, shoot, it stopped sharing it. Thanks for letting me know. I wonder if. No, you guys are good.
Oh, we get it.
But I'm not answering your questions. You can just watch. Does that sound good?
Yeah, it's a deal.
All right, is it on there now, Mitchell?
I-
I don't know if that's because of the Wi-Fi here.
It might just be the Wi-Fi here. Cause it still just says Markiplier.
Yeah, it says I'm sharing it.
Oh.
Is it good now?
It just came out.
It's good? Oh, perfect. Okay. Sorry, YouTube. Didn't realize that my screen wasn't sharing. I'm at the library today. All right, so do you see it? Do y'all see it? What would it be? Micah, tell me what it would be. What should I write for this one?
Which one?
This one here. 2 cosine squared 20 minus 1.
Cosine 2.
Very good. Cosine, y'all see it? He's using this one right here. So it's the same as the cosine of 2 times whatever A is, and A is 20. Make sense? See it?
Yeah.
That's the one that it looks just like. So he's writing this out, but he's substituting A in, and A was 20. So that equals what? The cosine of what? Cosine of 40, right? I'll write it like this. Cosine of 2 times 20, which is the cosine of 40. And that's your answer, cosine of 40.
Does
Good.
the -1 matter?
Well, look at this. The -1 was in here. So did it matter? Yeah, if it wasn't there, you couldn't use this.
So you just disregard it.
I'm not disregarding it. I'm just simplifying this. See how this is the same? What's the only difference between this and this. The A isn't A here, it's what? It's 20. So what should I put in here for this A? 20.
Oh, okay, no, I see.
It's not, I'm not doing algebra. I'm not like solving an equation. I'm rewriting it. Make sense? Good? All right, now we're doing identities. So to prove this identity, I'm gonna take, there's a couple ways you can do this probably, but what I'm gonna do is rewrite this. I'm gonna rewrite the cosecant. How can you rewrite cosecant? Kayla, is this good review for you? Kayla, is this good review for you? Is this good? Are you watching this? Is this good?
Yeah.
Because I can help you with the other stuff later too, but this might take us quite a bit of the time. So if you want, we can talk later about like me helping you with the polar stuff if we don't have a chance to get to it, because these guys have it
I think I mostly got it down.
with the polar stuff.
Yeah.
All right, so this is good review too, because this is something you're gonna have to do. Perfect. So cosecant is what? 1 over what? 1 over sine, right? And what's secant the same as? 1 over cosine. Everybody good? And how do I divide by a fraction? Multiply by the, which means this becomes what? Sine squared of theta. And this becomes what? Cosine squared of theta. And what does that equal? 1. Make sense?
What is sine square root of x? Does it matter? Is it
Don't write x because they have theta. They might mark off.
Okay.
If they had written x up here, then write x. But if they wrote
It's the
theta,
same thing though, right? Like, theta's the same thing.
it's different. It's a different, it's like x and y.
Like they're both variables.
They're both variables. Yeah. The property still holds. Just don't write it the wrong way because they might mark you off. So this next one here, let me just duplicate this page. So this next one might take a little bit longer. So let's move it up. All right, so the first thing we're gonna do, you guys okay with me just working like on the left side, right side like this? The first thing I'm gonna do is I'm gonna write 1 plus cosine x, but I'm gonna multiply this by the conjugate. You know that trick? So this is an important trick to know. I'm choosing to multiply it on the top and bottom by the conjugate of the bottom. That's one of those things, like, how would you ever know to do that? Because you've seen it done 20 times. So one of the things that you need to have in your toolbox when you're trying to do these problems is you need to have the ability to recognize that, oh, look, there's a 1 plus cosine x down there. And I know if I multiply that by the conjugate, which means just change the sign, what's going to happen right here? What happens when I multiply 1 plus cosine x times 1 minus cosine x? I get 1. Well, first of all, on the top, I get tan x times 1 minus cosine x. I'm not changing that. I'm not even distributing that. Just leave that for now. Good. And then on the bottom, what's going to happen when I FOIL that out, right? FOIL first, outside, inside, last. What's going to happen when I multiply that out? What's 1 times 1? 1. What's cosine times 1? That's cosine x, right? You with me? And what's negative cosine times 1? That's negative cosine x. So what happens to those two? They cancel, so I'm not even going to write it. Is that okay with everybody? And then what's cosine times negative cosine? That's negative cosine squared x. Got it? You get how I did that?
I just have a question. So when there's a 2 in front of the cosine, does that mean there's 2 separate cosines? But then otherwise, if there's a 2 before the x, that just means it's a
Double angle.
double angle identity,
Yep.
right? Okay. And then
It's a double
2
angle versus a double function. Yeah, the 2 in front of the cosine would be 2 times cosine. The 2 in front of the x would be cosine of 2x. And a 2 here would be cosine squared, which is the same as cosine squared.
So what does that mean? There's 2. Is that another like
Times itself, cosine x times
So
cosine
there's
x.
2. even if it's squared.
Yeah. So cosine squared x is the same as cosine of x squared, which is cosine x times cosine x.
Okay.
That makes sense?
Yeah.
All of those are the same. That's a good question because a lot of people are confused by that, but that doesn't have to do with this problem necessarily. I mean, I guess it kind of does here, but why did I want this squared here?
Can you translate that to something?
Yeah, remember this formula, look up upper right, sine squared plus cosine squared equals 1, which means if I subtract cosine squared from both sides, I get sine squared. So what does this equal? Sine squared. So now I get to write tan x times 1 minus cosine x all over sine squared x. Okay. Good. All right. Now, what I can do is also at the same time, I'm going to rewrite tangent as what? Sine x over cosine x. You all good with that?
Like, can you cancel?
Mm-hmm.
Like that's one of the signs.
Mm-hmm. And so now what happens is this is like sine squared x over 1, right? On the bottom. So I can flip and multiply, right? So I'm going to show you the work right there. So this is like sine x over cosine x times 1 minus cosine x times 1 over sine squared x. Y'all get that? Because I just flipped it and multiplied it on the top. Y'all good with that?
Mhm.
And now what happens to this and one of these? One of them cancels, right? So that's going to be gone with one of those to your question. Chase, was it? Chase, do you see how those cancel? Because there's two of them, sine x times sine x.
You know, I get that. It's just like I got confused because even if there's a 2 out in front, it still means that there's 2. Like,
If there's a 2 in front, it means 2, not sine times sine. It means sine x plus sine x, not sine x times sine x. That's the difference. So this is sine x times sine x. I'll even write it like that. Got it? And now one of those cancels. And you're just left with what? On the top, you have 1 minus cosine x. And on the bottom, you have a cosine of x and a sine of x, which I'll write in this order instead. And that's my answer.
My boss is calling me.
Boss?
I know, he knows I'm at school.
Tell him to
now.
quit being bossy. Okay, got it? You all good?
Yeah.
Make sense?
so the final answer B.
So I kind of ran out of room, but your different teachers want you to write it different ways, but I've pretty much gotten, see how that's the answer?
Oh, yeah.
So if your teacher might want you to write it like that, just all the way down,
Oh, okay, I got you.
right? So maybe you have one more step at the bottom that says that. Y'all good with that? Yeah, is he good?
Yeah.
All right, we're doing solving now. You ready? This is where the fun starts. So I'm gonna import a unit circle so that we can just quickly look at it. Y'all good with the unit circle? You know how that works? All right, this is my master unit circle.
Oh my God.
Yeah, it's the best because what it has on it, it has all the tangents on it as well. So the green ones are the tangents, okay? And you can see that the unit circle is actually just a bunch of triangles. So there's a video where I made this unit circle. You should watch it so you'll understand really what the unit circle is all about. All right, back to the story. How do I solve this? The first step is we try to isolate this right here. See how it's a quadratic? So quadratics, you could either factor a quadratic, which this doesn't factor, or you could try to isolate it if there's only one squared term, which there is. See how there's just one squared variable term? Got it? So for this one, we're gonna try to get that, what I just put a box around by itself. So first subtract or add the 3, right? And then divide by what? Can I do that all at once? Are you all okay with that?
Yeah.
Is he good? See how I did there? I added 3 and then I divided by 4. Is that okay?
Yeah.
Okay, now I do what to get rid of the square?
We wanna take the square root of each.
I want to take the square root. And when I take the square root of each side, I always have to make sure to put what there? A plus or minus. If you don't put the plus or minus, you're only finding one of the square roots of it. And how many square roots are there of, I don't know, let's say x squared equals 9. How many answers are there for x squared equals 9? There's 2. There's a positive and a negative. So you have to put the plus or minus there because there's 2. So it's plus or minus square root of 3 all over. What's the square root of 4? 2. So can I write it like that?
Yeah.
And hey, look at that. All of those are right over here in my unit circle. The cosine is what? X or Y? It's the x coordinate. You got it? So all of these are going to be the red triangles. See all the red triangles? There's a positive root 3 over 2. There's a negative root 3 over 2. There's a negative root 3 over 2. And there's a positive root 3 over 2. So my answers are going to be
Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.
perfect.
Dang, look at that. Look at this video.
All right. All right. So x equals,
You said that so many times I just decided to memorize.
yeah, just memorize it.
Okay, so can you actually repeat that? This-
It's right here.
Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6.
So 7 pi over 6. Okay.
Hey, watch my video on how to make that unit circle because you'll be able to do what he did. Radians are way easier than degrees because if you look at the reds, these are all 1/6 of a pi. And if you just count by 1/6, here's 1/6, here's 2/6, here's 3/6, there's 4/6, there's 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. And then reduced, right? I didn't reduce it as I was saying it. I was just saying it. But these are all reduced, right? The yellow ones and the black ones all are part of the 1/6. You can do the same with the blue ones. The blue ones include all of the axes. So there's 1/4 because blues are a fourth. The 45 degrees, there's 4 of them in 180 degrees. 180 degrees is 1 pi. So 1/4 of a pi. If I keep adding it, there's 1/4, there's 2/4, there's 3/4, there's 4/4, 5/4, 6/4, 7/4. Make sense? So radians are simple. People think they're so hard. They're actually much simpler than degrees. Because degrees, you're adding like 30 and 15 and 45, right? It's much harder to add 45s than just to add 1/4, 2/4, 3/4, 4/4, 5/4. Much easier. And the more you do it, the more it makes sense. So that's why Mitchell didn't have a hard time with that. So let's do the next problem. So there's a video on YouTube. Watch it if you need. All right, check this one out. What I'm going to have to do here, notice again, I've got 2 different variables now. Here I had 1 variable, but it was squared. So I knew it was a quadratic. So to solve a quadratic, think of algebra 1 or algebra 2 trig. Quadratics, you have to use factoring or quadratic formula or getting lucky and just using the square root principle. Now for this, unfortunately for this, they've never given you a hard one where you have to use quadratic formula, but they could have. They just don't for you guys. For an honors pre-calc, they might, but for you, they don't. But this one, what I'm going to do is subtract. I have to remember with quadratics, you have to set it equal to 0. Do you remember that? If you ever want to factor, remember how you have to set it equal to 0? So why do I have to set it equal to 0? Because to solve it, a quadratic, you have to use the 0 product property. If something, look at my screen, if something times something else equals 0, what has to be true about A or B? One of them has to be 0. If I told you that A times B equals 1, does that mean squat? It doesn't mean anything. A and B could be whatever the heck you want, right? There's no value in this. That does nothing for you. This, very valuable. Because if you have a product, you see how I have a product here? A product is 2 things that are being what? Multiplied together, right, Izzy? I'm not losing you, right? So here's the value of set equals to 0. Now when I factor out, right now, do I have a product? Do I? Is this a product? Is the left side of my equation a product?
Yeah.
It's not a product because it's being what?
Subtracted.
Kayla, this is good for you too. Because it's being what? Subtracted. How do I make it a product?
Get rid of the subtraction.
It's the F word of math. What is it? I factor it. I factor because when I factor it out, now what do I have? Square root of 2 cosine x minus 1. Y'all see how I did that? Now what do I have? Now I have a what? That times that. Do you see how I have a product now? Do you see how I have this times this equals 0? And if this times this equals 0, what can I do? I can say either sine x equals 0 or root 2 cosine x minus 1 equals 0. Do you remember doing that before? Remember doing that? In algebra 1, algebra 2 trig? Well, we did.
This basically.
That's why you factor.
It was over Zoom, like, don't worry about it.
No. It wasn't over Zoom. It wasn't over Zoom because I've been tutoring Izzy for years.
Oh, either.
It was not over Zoom. Yeah, I know.
They just admitted it to all.
Now what can I do? Now for this one, I say the cosine of x equals what? Add 1, divide by root 2, right? Got it? Everybody got it? Good? Good? Yeah, I just did it in my head, right? Hey, this one, where does that equal? Look at your unit circle to the right. Where is the sine of x equals 0?
Isn't that
Sine is the y.
0 pi.
It's at 0 and pi. Got it? And where does the cosine equal 1 over root 2, which is the same as root 2 over 2, right?
That is gonna be pi over 4 to, no, it's pi over 6.
The cosine is positive. That's your x coordinate. So it's first quadrant and fourth quadrant.
Pi over 3.
Not pi over 6. You're all wrong. It's pi over 4. Look at the blue one. Look at the blue one. Where's root 2 over 2?
Oh, it's pi over 4.
What's 1 over root 2? What's 1 over root 2 the same as? Root 2 over 2. Y'all know that?
Yeah.
So where is the cosine positive root 2 over 2? Quadrant 1. Sorry, quadrant 1 and 4. You're right. Quadrant 1 because it's the x coordinate. Quadrant 1 and quadrant 4. So it's pi over 4 and 7 pi over 4.
Memorize that.
The unit circle? You have to, or are you asking me or telling me? So you don't memorize it, you just write it. Did they give you a little blank one?
Yeah.
So then just draw it. Get in the habit of drawing it. Like I said, I created this one before on my YouTube channel. It's actually probably in the last 2 weeks on my streams, my live streams. This exact one that you're looking at, I created that and explained it to you and showed you how to create it really easily. So just watch it. It'll teach you a lot about trig.
You create that one for me.
I don't remember.
It might.
It probably at one point I probably did, but I don't know if that one exactly. So my answers are what? Pi over 6 and 11 pi over 6? 7 pi. Oh my gosh, I'm an idiot. Pi over 4 and 7 pi over 4. You guys are rubbing off on me. So someone else said that. Those are your 4 answers. Got it? So this equation has how many answers? 4 between 0 and 2 pi. I'm assuming that's where they wanted you to answer it. Yes. If not, you'd have to do some other tricky stuff, but I don't think they've taught you that yet, have they?
Check this out. Pi over 4. Oh, my God. Pi over 2. No. Stop. Pi over 2. Pi over. Shut up. Get on my face. I thought I got it.
Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi.
I told him the question. You do that.
All right, you ready? Let's do the last one. Ready? I'm going to factor out a what? Do you see how there's a sine squared I can factor out? Do you see that? So when I take a sine squared out, what's going to be left? What's going to be left here? Careful.
-2.
Careful.
1.
Micah, why is there a 1 left there, Micah? Yeah, because I took this entire thing out and I don't leave a 0 there. If a 0 is left there, what's 0 times sine squared? It's 0. I have to have a 1 to hold the place. Does everybody get that? And what's left here if I take a sine squared out? -2 and cosine squared x. Do you know what to do now?
You gotta separate it, man.
You gotta separate it out. Sine squared,
0 and 1 minus 2 cosine squared x equals 0.
that's it. Now what? This means that sine x equals what? 0, right? And this one means, let's solve this in our head. Cosine squared, not entirely.
Plus 1 over
Cosine squared equals subtract 1, divide by -2, gives you what?
Oh, it's gonna be root positive and negative root 2 over 2.
Not yet. Let's first just do that. Positive 1/2, right? Because it's negative divided by negative. Yes, everybody? And now I have to take the what? Square root. And when I do, I get what? Cosine x equals?
Positive and negative root 2 over 2.
Exactly. All good with that, everybody? Good?
Wait, hold on. For the final answer, I got 1 over 2, but then
Then you have to take the square root of it.
square root.
The square root, because it's, see the square here? How do you get rid of the square? You take the square root.
I didn't get rid of that.
And in order to take the square root of this whole thing, don't forget the plus or minus, right? And then when you take the square root of it, you're gonna have 1 over the square root of 2, which is the same as that. So where are all of these answers?
So you're gonna need 0 and
It's basically all the blue. It's all the blues.
pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.
Yep, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4.
And then for the sine of x, you're gonna need.
And where is the
0 and
sign? Remember where the sign is the y?
0 and y.
So that's 0 and pi again. So 0, whoops, 0 and pi. So here are your answers right there. There's 6 answers.
So just real quick, can you go over like the 30, 60, 90 lines, like for like pi over 3 or like pi over 6? Because like, I don't know, like for pi over 6, what would that be like? How would I know which one it would be? Like, I'm just so confused by that with the cosine.
So here, look at this triangle, this red triangle.
Uh-huh.
Which one is bigger, this side or this side?
Or the long side. Like I know like this pi over 6. Like I know that.
No, but which one of these lines is bigger?
The bottom line.
The bottom line is bigger. And which one of these numbers is bigger?
It would be x. Whatever x is.
Yeah, the root 3 is bigger. Root 3 is bigger than 1. So root 3 over 2 is bigger than 1 over 2.
Mhm.
So the x, which is the horizontal, is the bigger one. And the y is the smaller one.
Okay.
That make sense?
No, yeah, I get that. I'm just trying to figure out like the other points around like.
So how you can add them up?
No, just.
Or how you can find the radians?
No, just memorizing them. Instead of like one of them's like 5 pi or like something like that. Like.
Yeah, so what you do is start by just count by 1/6 of a pi. So here's 1/6 of a pi. Here's 2/6 of a pi. Here's 3/6 of a pi. I'm just going 30 degrees. There's 4/6, there's 5/6, there's 6/6, 7/6, 8/6, 9/6, 10/6, 11/6.
Okay, I got you.
Got it? And you can even count by 1/3 of a pi if you want, but you already did it if you counted by 60s or 30s. There's 1/3, there's 2/3. Notice I skipped this one for the yellow. There's 3/3, 4/3, 5/3.
So the
6
yellows don't
thirds.
count for the pi over 2.
The yellows you don't because this is the yellows are 60 degree.
Oh, right.
See, I don't have yellow right here
No.
and I have yellow here. That's why I put those colors there so you can see how to count them.
Okay.
Again, you watch that video and you'll see what I'm talking about. All right. Verify or prove the following. What does that look like to you? Something you don't want to do. Well, the first thing I'm going to do is I'm going to say, oh, hey, I'm going to factor out a 4. And what else can I take out? A sine. And what else can I take out? One cosine. So if I take a 4 out and a sine out and a cosine out, just watch, don't write it, just watch. This one's tricky. If I take a 4 and a sine and a cosine out, what's going to be left here? Just how many of these will be left? There were 3 here. How many are gonna be left? There's gonna be 2 left. So that's gonna be a cosine squared x. Got it?
You don't have to write 1.
No, because it's not, there's something else here. You could write a 1 in front of it if you want, but you don't need to. And what's gonna be left here if I take a 4 and a sine and a cosine? What's gonna be left here? It's a minus, good, sine squared. Got it? Okay. Does this look familiar to anybody?
And then you do the same.
No, a plus would equal 1. But look at your sheet. There's another thing that equals.
Is equal 0.
No, look at it. Look for it. You'll see it. It equals cosine 2x, isn't it? Isn't it cosine 2x?
Isn't this the sum of differences?
Yeah.
Nope. Look, I'm looking at the sheet that we dropped on here earlier. Look at one of the properties down here.
Oh, it is.
Do you see it? Do you see it? Y'all see it? That's what you gotta know. You gotta know how to use these formulas.
The ones with the dots, she said we do not have to memorize, by the way.
Yeah, and you shouldn't memorize this one, but you should definitely know where it's at when you have to use it, like now. So that equals cosine of 2x. Y'all got me? So this is the cosine of 2x. So this is cosine of 2x. And hey, if I take, doesn't this look really familiar to you? Doesn't that, if this was a 2, wouldn't that be the sine of 2x? Go back to that formula, you'll see it. Y'all see it? And it is. And so what I do is I rewrite this 4 here, and I rewrite that as 2 times 2 sine x cosine x, because now I know that this thing equals what? What does this equal? Thank you. That equals the sine of 2x. So now I have 2 sine 2x cosine 2x. And hey, can I use that same property? If I have this and a 2 in front of it, doesn't that just equal double whatever this was? It does. And what was double of this? What's double of 2x? 4x, and that's what I wanted. You might have to go back and watch. I used this formula a couple times. 2 sine x cosine x. Here, I'm going to write it differently so you can see it.
It's equal to.
Yeah. 2 sine u cosine u equals sine 2u. So see how I had that here? This is 2 sine u cosine u. So this is 2u, and u was 2x. So that's 4x. Makes sense? Makes sense? I know that was kind of tricky. That's why I just wanted to watch it. Solve the following equations over this interval. Find all the values for x in radians. Hey, what does this look like, everybody? Doesn't this look like a quadratic equation? And wouldn't it be really nice? You don't need to use a quadratic probably, but you could. But what's the other way to solve a quadratic besides quadratic formula? If possible, factoring. So watch, has your teacher taught you how to let u equal cosine x? Have they ever taught you that? So that just helps you look, that just helps you see it a little bit better. So this would be like u squared plus 2u plus 1. Y'all got that?
Wait, sorry, plus 2u.
Yeah, do you see how I substituted u? Instead of cosine x, I wrote the letter u.
Why is that?
Just because it's easier to see. So
Why is it not 2? I thought you factored out the cosine.
no, what am I saying u equals? I didn't factor anything out yet. This is called substitution.
Okay.
Have your teachers done this?
Yeah, no, we've done that.
Have you done this? Did your teacher do it this way or no? Some teachers don't use the u. Some teachers just go straight to the answer. It doesn't matter to me. I just don't want to confuse you. Have you seen the u, Kayla?
You did it with me last time.
Have your teacher not used that though?
I've done it with you, but Ray-Ban hasn't used it.
Okay. It really doesn't matter, you guys.
So you have Ray-Ban first.
The reason I would use the u, the reason I'm showing you with the u is because it may help you see it better. If I gave you this problem, how would you factor this? Do you see it? Do you see what you would do? It would be u plus 1 and u plus 1, right? So the only reason I put it in the u in that form is because it's easier to see. But really, what's u? It's the cosine of x. So really, I have cosine x plus 1 and cosine x plus 1. You get what I'm saying?
Yeah.
Did you get that? So now what can I do with this?
Oh, then you can do
It
cosine x
cancels
plus
out.
0.
I set them each equal to 0. So and really they're the same thing, aren't they?
Yeah.
So do I even have to do it twice?
No. I mean.
And now what's the solution for this? Cosine x equals -1. And where does that happen? Look at your unit circle. Remember, remember cosine is your x or your y. So where is that? Think of your unit circle. Look at my hands. In your perspective, where is the x-axis -1?
Oh. 0 and
At pi, not at 0, not at 0, at just pi. Got it? Don't get fooled by that. Don't mess that up. X equals pi. And there's your answer. And if you're not sure if that's true, all right, Chase, you're gonna flip out right now. Take your calculator out and take the cosine. Whoops. Do the cosine of pi. Do they let you use your calculator?
No, they don't.
Crap.
I wish.
Whoops. Sorry, I did that wrong.
Mr. Boyer, you were saying.
I punched that in wrong.
That my teacher would change her mind about using calculators. It is still a no calculator.
I'm so sorry about that. All right, watch. I'm going to show you a really cool trick. I'm going to type in pi in my calculator. Everyone watch this. You're going to love this. Store it. You see that store button, lower left corner, one up from the bottom left. You see that little STO button? Type in the number that you want to check, hit that store button, and then hit X and hit enter. Now, every time you type in that X, it's going to substitute that number in, which is pi. So what? 2X is going to be 6.28. Got it? Now, why would I do that? Because now I can just punch in this right here into my equation with the variable. I'm going to punch in cosine squared X. So cosine, I have to be careful with this. I'm going to have to do cosine X quantity squared. So actually I have to do it like this. Cosine X squared. Okay, that's cosine squared X. Got it? Plus 2 cosine X. Close off the parentheses. Plus 1. And what should I get as my answer? If it was right. If my answer is correct. If the answer is pi, I should get 0, right? Right? Because when I plug in pi, I should get 0. Hit enter. And it's wrong. Does that mean we did that wrong? Or did I punch it in wrong? Cosine X squared. Cosine X plus 1. Are we sure we got the right? Oh, am I in radians? That's the problem. I'm in degrees. I need to be in radians on my calculator. My bad. So watch, I want to teach you this other trick. Hit second enter and it gives you that same thing back. Now hit enter again and what should I get?
0.
Let's hope I do.
You hit alpha plus. I want to see if it works in your calculator.
Alpha what?
Plus.
Alpha plus. I don't have plus now.
Oh, look, alpha, you have the minutes.
Oh, minutes? Yeah, nice. All right, let's do the next one. Ready? Are we good? Are we learning? Are we getting this? Any questions?
Wait,
Are you with me?
I have a question. I didn't do the substitution. What I did is I just tried to factor it. Like I just took
Yeah,
the
that's fine.
answer.
You'd get the same answer.
Yeah, but isn't that way like easier? It looks much easier. Just like substitute
This way or your way?
your way. Like it make like
In my mind, it's easier because you're not confused by the cosine. It's the same thing. Some teachers just teach you to go straight from here, straight to here.
right. Okay.
Can you see how to do that? If you can see it, then do it. But if it's more confusing for you to see it that way, write it in a simpler. All the U substitution is writing it in a simpler way, right? So that you can visualize it better. Like for most people, it's easier to visualize how you factor that than it is to visualize how you factor that. But it's the same thing. Doesn't really matter. So some teachers prefer to teach it one way, some another. All right, what do I do first for this one?
This one, yeah.
Can I divide by something? Is that going to get me anywhere? Because that's what a lot of people do. They want to divide, right? Because that's what you do. You divide. What's the problem with dividing? This is not a linear equation, right? This is a quadratic equation. I got two different x's and sine and a cosine, right? It's a big old mess. So I can't divide. Instead, I have to set it equal to 0. Are you getting the point that I'm trying to make here? You have to set these problems equal to 0. That goes back to algebra 1 and algebra 2 trig if you were learning anything in those. So add 3 sine x to both sides. Why did I do that? Because I've set it equal to 0. Good job, Izzy. Oh, hey, is this good right now? Can I start factoring? Why not? Because I have what? Now I have a sine and a what? Can I solve if I have a sine and a cosine? Not very easily. I'd like to turn one of them into the other one. And which one can I easily turn into the other one? I know you know. Which one of these can I turn in? Why cosine? It's not really cosine, it's cosine squared. That was what I was looking for there. So sine squared plus cosine squared equals 1, which means I want to change this, right? Cosine squared equals what? 1 minus sine squared. Do you see how I did that?
Oh, is that only when it's like squared though, right?
Only when it's squared. And it goes back to the unit circle, but I'm not going to show you that again. So this is 2 times 1 minus sine squared x plus 3 sine x. And now I can do what with this? Factor or distribute the 2 in, right? Y'all good? Can I just go? 2 minus 2 sine squared x plus 3 sine x equals 0. Now what kind of equation do I have? It's a, what kind of equation is it? When I have something squared in it, it's quadratic. Hey, do you like the -2 in front of the squared term, or do you rather it be positive?
Really doesn't matter.
I'm guessing you would rather it be positive. So how can I very easily make everything positive, or make that positive? Change the signs of everything. Multiply it by -1. So I'm going to multiply everything by -1. Is that okay with everybody? So this becomes a negative, that becomes a positive, and that becomes a negative. And then I'm going to write it in order so you guys aren't confused. You ready? 2, oh, and also I'm going to rewrite it as u equals, let's try this again. Let's write u equals the sine of x now. You don't have, do you have to do this? No, but it might make it easier. So this is 2u squared, y'all with me? Minus 3 what? U, remember we're calling it u, minus 2, y'all with me? Equals what? 0. Now, can you use the quadratic formula? If you want to, but I bet you it's going to factor. And in fact, I bet you it's going to factor kind of nice. So you get those numbers on the unit circle. It doesn't have to, but in your class, usually it does. So when I factor this, you guys remember doing this? One of them is going to have to be a -2 and a +1, something like that. So guess and check. Let's see. Notice I just split this up, 2 and u, right? 2u and u. And then this has to split up here and here so that this equals this. Guess and check. How about 2 and 1 here? Would that work? If I put a 2 here, let's say a -2 and a 1 here, a +1, would that work? It would not. How about if I put a 2 here? What's 2 times 2u? 4u, and then what's 1u? Oh, 4 minus 1 is 3. So that would work, but which one needs the negative?
The 2.
Good job. -2 and a +1. If you don't understand that, go back and watch YouTube videos about factoring.
You just want our subscriber counts to go up. You
Please,
so confused.
please, two more.
Come on.
Give me two more.
Why do you need to?
I don't need any more. I'm good. I don't even need money. So rich from YouTube. I make like $120 a month on it.
You are. Yes.
Make it roll, make it rain. So do you get what I'm doing here? So what does U equal? U equals, let's just do this in our head, shall we? -1/2, right? And U equals 2. Oh, geez. I don't like that.
Isn't there an easier way to do this?
That means sine equals -1/2. Oh, yeah, no, that makes sense. That's all good. I'm gonna erase this because I need that room now. So that means the sine x equals -1/2 and sine x equals 2. Hey, can sine x equal 2 ever? Can the opposite over the hypotenuse be bigger than 1? Can the opposite ever be bigger than the hypotenuse in a right triangle? You guys get what I'm saying? So this is called an extraneous solution, so just cross it out. But how about this one? Where's the sine x equal to -1/2?
Chase.
Stop my kid, don't put me in the spot, I'm gonna freak out and I won't figure it out.
You can do this, buddy. I believe in you.
Wait for a negative sign. Is that
So what is the sign first? Is it x or y?
what? That'd be like pi/6, but on the under and quadrant 2.
Okay, is it x or y?
This is y.
Good. So if it's negative, which quadrant does it have to be in?
2.
2,
Or no, 4. That'd be
4, or not 1. Where is it negative? Where's the sign negative?
Oh no, it'd be 1 and 2 because it's y.
No. Where's the sign? Hey, look, where's the y negative? But anything below? It's got to be 3 and 4, right?
Yeah.
Okay, that's how you think about it. So where now you think, okay, it's in these two quadrants, and where is the sine 1/2? Here's how I think of it. The sine is it the opposite or the adjacent? The sine.
Oh, it's opposite.
It's the opposite. So the opposite is the smaller side, right?
No,
Which means the adjacent is the bigger side. So it's the 30-degree angle there, right? It's the 30-degree reference angle. So it's those ones. So it's going to be, this is where you count. This is where Mitchell rocks. There's 1, 2, 3, 4, 5, 6, 7, and 11, because it's 1 less of 12. So it's 7 and 11. So it's 7 pi over 6 and 11 pi over 6. You counted by 6 because it's the 30-degree angle.
Remember this. Pi/6, 5 pi/6, 7 pi/6, and 11.
Yeah, he thinks of it like that too. He just has those memorized. He has these ones right here memorized.
Lucky.
Well, I mean, you already memorized it, so in that sense, you're lucky. So I still memorize it, so.
Takes work though.
You know.
Good. You guys feeling more comfortable with this stuff?
Yeah.
Izzy, how about this one? What are we gonna do? Are we trying to solve this or approve it?
I didn't write this.
Solve it. Solve?
I think I put this one up there.
Okay.
I don't really, you don't have to do it.
No, let's do it.
I don't know what it's asking.
It probably says solve between 0 and 2 pi.
What would happen if it was like so and turn 0 pi? That means you only find like 2 solutions instead of like 4.
Mhm. Or however many there are. So
Oh.
what do I do first for this one?
Subtract 1.
Good. Now, there's actually a couple ways you can do this technically, but no, let's not. Let's subtract 1. I like that. You could try to factor it. It might factor, but I like your idea better. Subtracting 1. Yep, thank you. And now what? And it's a good thing it was still negative, because otherwise you'd have no solutions, because you can't take the square root of a negative number. So that has to be a positive there, because now I have to take what?
Square root of each side.
Square
So it
root.
should be Sine of x equals √2/2, so positive, negative, so it's gonna be
Those are all your what? All your what angles?
45 degrees, so it's gonna be pi/4, 3 pi/4, 5 pi/4, and 7 pi/4.
Yep.
This is all the 60 degrees.
No, it's all the 45s, which on mine are the blue ones.
Okay, I'm gonna,
Root 2 over 2.
I am stealing your art right now.
No, √2/2. √2/2 is all the blue ones, all the 45s, the pi/4s.
Does this include the, include the X and the Y.
Yeah, so notice because it's positive and negative, it includes both. It's the sign where it's positive or negative. So it includes all the blue ones.
Okay, so pi over 4, pi over 2. 3 pi over 4. Stuff like that.
Yep.
I have a cool question. So like almost like these were like, I don't know if you can see it, but like number 3.
Get Micah to ask it. Get Micah to ask it.
What's up? You might get asked it.
Yeah.
Oh, okay.
He knows how to put it on there.
Number 3. He would ask the question.
Like put it on the slideshow.
Oh, yeah, I got
All right, let's try this one, page 11. Kayla, how you doing over there?
Doing good, I'm doing delta math.
Okay. I'll at some point, hopefully I'll be able to help you. But if you want to keep watching this, you're welcome to too. But if you want to do that, great too. All right, you ready? What should I do for this one? Doesn't this kind of look like a formula that I should have on my little formula sheet? It kind of does. Doesn't it look like one that said sine A cosine B minus cosine A sine B?
Yeah.
Sure looks like that. And isn't that a formula that says something like, I don't know, sine A minus B or something? Can you look up your formula sheet? Isn't this like this? There you go. So let's write it. Ready? Tell me what to write. If it's sine A minus B, it's sine. What's A and what's B? Okay, now, hold on. We're not done.
And then you change it into degrees.
Did they tell you to do that? You can do that.
I think so.
You can do that, or you can,
It would be 6.
but hold on. They probably want it in radians. They probably want this in radians.
Oh.
So can you guys tell me how to do this fraction wise? How do I add these together? I find a common denominator, which is what? 6. So this is sine of 3 pi over 6 minus 2 pi over 6, which is what? There you go. Okay, that's probably how they want it. If they give it to you in radians, they don't want the answer in degrees. But if it's easier for you to do degrees, just convert it back. That's fine. If you did it, you would have got sine of 30, but then you just want to convert it back to pi over 6. Okay? Because I'm sure that's how they want it. How about this next one, number 6? Does it look like a formula you've seen?
Yeah.
Which one is it? Look it up.
Oh, that's the some difference.
Isn't that cosine 2 theta? 2a? So is this your a right here? Is this your a?
Yeah.
So this is just cosine 2a. Right? And then what do I do with the 2 and the 6? Can't they cancel? You guys should watch this because you might be confused. Yep. This cancels and it becomes 3. Cosine 7 pi over 3. That's your answer.
Should I go buy sushi after this?
This is so like.
Oh yeah, Amazon Prime.
Definitely.
Or is it Amazon Fresh? Amazon Fresh.
Don't go to Amazon.
Sushi is
Dude,
so good.
Go to Caputo's.
Hold on. Did they
Bro,
wait? Hold up. Did they want us to? Oh yeah. You have to make sure you read the directions. It says write them as a single sine or cosine. They didn't say to simplify it. They just said write it as a single. I was thinking maybe they want you to give the actual answer for this, but they didn't. The answer for this would have been 1/2. The answer for this would have been something else. But they don't want you to do that because it just said write as a single sine or cosine. So I'm glad I saw the directions. How about this one? Doesn't that look familiar? That's the tangent one. Is it the tangent plus or the tangent minus? It's the tangent minus. It's the same sign as the top. Is that right? I'm not looking at it, so I don't know. So this equals the tangent of 50 minus 30, which is just the tangent of 20. Okay. Right? We just did this one.
Sine 2a.
Sine 2, and this is your a, right? Right? This is your a. So this equals the sine of 6x. Got it? Because your a is 3x, so it's the sine of 2a. So 2 times 3x is 6x.
So you multiply the 2 by the 3.
In this case, yep. Because
Is that like a normal truth? Like,
it's because 2 sine u cosine u equals sine 2u. And that's
okay.
what I'm using. I'm using that property. We did that once before. Solve the equation over the given interval. Okay, you guys ready? This one's a little different because of the interval. Look at the interval. This one's going to stump people on the test if it's on the test.
Doesn't that mean it's from just like the left side all the way to like the right? Isn't it just like the 180?
Yeah, but it's from the negative pi. So they don't want you to go from, they're not going from 0 to pi, or they're not going from 0 to 2 pi. They're going from negative pi. Let me see. How am I saying that?
Just the 180, like anything above the 180, right?
No, because negative pi. Hey, what's up, Brady? Negative pi is right here. Yeah, negative pi is here, and positive pi is also here. So they want you to solve it from negative pi to positive pi, but they don't want you to write it, these numbers in here, like we have them written, because they want the negative ones. So you remember how there's different ways to write this? You could have written this as negative pi over 6 or 11 pi over 6.
So when it's asking for negative pi to pi, you just look at the third and fourth quadrant?
Yes, but you're looking at the whole thing, but you're not writing it as 0 to 2 pi. You're writing it as negative pi.
It's just doing it differently.
You're just writing it differently. So if your answer would have been 11 pi over 6, you don't write 11 pi over 6.
Does that mean that?
You write negative pi over 6, right? They're the same thing. Negative pi over 6 is the same as 11 pi over 6. They're coterminal. Yeah. So you're writing it differently. The answers are the same, but you're writing it so that it's between negative pi and positive pi. Do you get that, Izzy? Micah, do you get that?
Yeah.
So,
You get what I'm saying with that? All right, so let me just show you, and then I'll do it for you. So what I do first is I get rid of the 4, and I can divide that by 0, and I still get 0. So it didn't actually matter. So the sine squared of x equals 0, which means really just that the sine of x equals 0, right?
Mhm.
And where does the sine of x equal 0? Look at your unit circle. The sine is your what? It's your y. So where does the y equal 0? It equals it at here and at here, right? So it equals that at pi, which is also negative pi. But look at how they're trying to trick you here. See those open brackets? Mitchell, you see that?
Yeah.
Do I include negative pi and positive pi in my answer? I don't include them because of the brackets. So what's my really only answer? My only answer, what's this one?
0.
Is 0. The only answer is x equals 0. That's the only answer for that one. Now, if they had asked me to find the answers if they said find the answers between 0 and 2 pi, then what would my answers have been?
Where is it?
If they had asked you, instead of negative pi to positive pi, not including, remember how most of them look like this? Remember how most of them look like this with that bracket and the open parentheses? If they had said this instead of this, what would you have done? What would the answer be? Now it would be 0 and which other one? Because still my answer is just where? It's this point or this point? Well, it can't be 3 pi because 3 pi isn't in here. How about 1 pi?
Oh, yeah.
Couldn't it be 1 pi?
Yeah.
So your answer would have been 0 and pi if they had asked you this way. Do you get what I'm saying?
Not really, to be honest with you, I don't know. Like, I just don't understand how, like, what you mean by, like, going the opposite way around. Like, how, like, What are like the points there?
Do you remember how this is your initial side and positive angles go counterclockwise and negative angles start here and go clockwise?
Yeah.
This value right here, this X going this way counterclockwise is called pi. But if you went in the negative direction, it would be negative pi.
Oh, okay. I was just confused because like the way you were drawing it, you were like going like that. And I was just like,
This angle right here can be either 11 pi over 6, or it can be what else? Negative pi over 6, or you can add and subtract 12 pi over 6.
Oh, no, I get it. Never mind. Sorry.
Because if you're going this way, it's 11 pi over 6, and if it's going this way, it's negative pi over 6. Got it? So the answer for this, you have to look at where they're telling you the domain is. They only want, remember, there's an infinite number of answers to this problem, right? There's an infinite number because the sine graph, think about it, it goes like this. Where does it equal 0? Look at your sine graph. Where does this equal 0? It equals 0 here, 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 and it keeps going in both directions, right? And it's going to equal 0 every time it hits 0, right? But they only want the solution between 0 and 2 pi, usually, right? Between there and there normally. But in this case, they didn't tell us there and there. Where did they tell us in this case? They said between negative pi, which is right here, but they said don't include that, right? I'm sorry, positive pi from negative pi would be right there to right there. You get what I'm saying? And if we can't include that or that, there's only one solution, that one. And that's why your answer was 0. Seeing eyes glazing over. It's getting too much, right? All right. Are we good? Next one. We ready for the next one? Ideas. Any ideas? How do I solve this crazy problem?
What do you want to factor?
Yeah, I have to convert this to what?
Oh, multiplication.
Let's use a double angle identity.
Yeah, 2 sine.
There you go. How about that? How about converting this to 2 sine x cosine x? And then this still stays sine x. And now, someone tell me what to do. Not yet. Remember, what do I always say? When you have a quadratic, what do? I have to do what? Can I set something equal to 0 yet? Not until I have a what? I'm factoring out the sign so that it turns from a sum. See how it's a sum right now? To a product. And if I have a product that equals 0, that's what I'm trying to get you guys to understand here. This is algebra, basic algebra, but you guys didn't have it because of COVID. A lot of you didn't really learn this. This is part of the reason you guys are struggling with this is because you didn't have. Everything we're doing here requires you knowing the stuff we've done before. And there's so many gaps in many people's understanding. So I'm trying to reteach you this as well. So now I can do what? Because I have a product, see that? This times this equals 0. Now the only way that can happen is if either one of these equals 0. And now I have 2 linear equations, right? And the linear equation, we can solve those very easily. Just get the x by itself. So that equals -1/2. And where does the sine equal 0? I'm assuming it's between 0 and 2 pi, yes? Is that where they want us to solve this, between 0 and 2 pi? Or was it negative pi to pi? It was?
Was that?
It's probably 0 to 2 pi. Usually you don't see the negative pi to pi. And how about the cosine of -1/2? Where does that equal? Think of your unit circle.
Oh, that's pi over 3, 2 pi over 3, 4 pi over 3, and 7 pi over 3.
Yeah, the cosine is the x coordinate, so it's the 60-degree angles, right? So it's the 60-degree angles, and it's the negative one though. So it would be in the second quadrant. It would be in those 2 quadrants, right? Because the cosine is negative in the second and the third quadrant. So this angle is 2 pi over 3. No, you're right. Remember, if you learn how to count by pi's over 3, here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So this is 2 pi over 3 and 4 pi over 3. Or you can look at your unit circle.
You said that there's gonna be like negative pi to pi.
So make sure you review what I just showed you on the last one. Watch that again if you don't get that. Well, here's a new
You guys
one.
have a different test than you did that? 'Cause I don't, our teacher didn't say that was gonna be on the test.
I've been drawing a different test.
I think that like supposed
Or
to.
Ray-Ban just doesn't know.
Wait, so I thought in the first
But you want a
quadrant.
breakdown?
Am I what? Yeah, I'm a junior.
All right, you guys ready for this one? You guys ready? Let's do it. Any ideas for this one?
Is that 2 over?
Okay, now I've got 2 new people here. Just pay attention, try to follow this, because everyone else I've explained this to. Everyone else, Izzy, you haven't been here a while. I'm gonna use you again. Okay? Some teachers don't use this, but I'm gonna let you equal 4x. Okay? Stay with me. Do not gloss over your eyes. You have to pay attention. If I told you that the sine of u equals √3/2, what would your answers be for that? Think of your unit circle. If I told you that the sine of u, I like that focus, guys. It's what? It's what? No, you're wrong.
11 pi over 6, bro.
You're wrong. You're wrong. I like the focus and the energy, but you're wrong. Where is the sine? The sine is the x, is the y. So it's pi over 3 and 2 pi over 3, right? So it's, got it? Pi over 3 and 2 pi over 3. Now watch. It's going to revolutionize your life if you understand what I'm about to tell you. Brady, you too. Am I trying to solve for you?
No.
Heck no, I'm trying to solve for x. So let's plug 4x back in for you. Got it? So I'm doing it for both. Remember, I had 2 answers. There are my 2 answers. Now I'm plugging 4x back in. Don't write, just watch, because you'll be able to see this later. Okay? Okay, so how do I solve for x right now? Multiply by 1/4 or divide by 4, right? So what does x really equal here? It's pi over 12. Everybody get that? Did you get it? And x equals 2 pi over, I'm going to go ahead and write 12, even though I could write pi over 6.
Yeah.
I'm just going to write 2 pi over 12, okay? You're going to see why in a second. Okay. Now,
That makes no sense.
what made no sense?
Why would you just be like, oh, I'm just gonna write 2?
Well, all I'm doing, I just divided by that, and I'm not reducing. I'm not reducing yet. That's all I'm saying. I'm not going to reduce it to pi. See how I multiplied the 4 and the 3 together? That gave me the 12. That's all I'm saying. I kept the 2 now, and you're going to see why in a second. Okay? Now, I'll call you later, okay? Give me a call. So this answer is only part of the answer, because really what happened to my period when I had the 4x here? What happens when you have a b? Remember when b is 4? B is a number. What happens to your period? Not doubles, it quadruples, right? Right? Your period, actually, it not quadrupled, it 1/4, really. So normally your period, look at this picture. Normally between 0 and 2 pi, right? Isn't that normally what your period is for a sine function? And doesn't it go from 1? Does this ring a bell for everybody? It goes up to here and it goes down to there. And isn't that your normal sine graph?
Yep.
The period is normally what? 2 pi, which means it completes an entire cycle in how much? 2 pi. But when I have a 4 here, what is my period really? The period is really 2 pi over 4, right? Remember that? 2 pi over b. You remember that trick? 2 pi over b. So it's pi over what? 2. So normally it would take a full 2 pi, but now it only takes pi over 2 to go through the entire cycle. Watch this. It went through the entire cycle in pi over 2. And then it's going to go through the entire cycle again. And then it's going to go over the entire cycle again. And then it's going to go over the entire cycle again. How many times did it complete a cycle in the normal amount of 2 pi? It completed it 4 times. You get what I'm saying? So how many answers? If I normally would have had 2 answers, now I have really how many answers? I have 4 times that, which is what? 8. Look at this little interesting thing here. Do you guys know where 3 pi over 2 is? It's like up here. It's like right about here. That's 3 pi over 2, or root 3 over 2. Do you know that? It's like a little less than 1. Right? Root 3 over 2. Watch. That is where all of your answers are going to be. Where were my answers originally? Pi over 3 and 2 pi over 3. That was this right here. Pi over 3 and 2 pi over 3 in the black one. See the black one? I'm going to write them in here so you can see it. That was your pi over 3. And that one right there was your 2 pi over 3. See how they're in the first and second quadrant? Here's your first quadrant. Here's your second quadrant. First quadrant is from 0 to pi over 2. Second quadrant is from pi over 2 to pi. Got what I'm saying? But now look how many answers on the red one I have. 1, 2, 3, 4, 5, 6, 7, 8. I only found 2 of them so far. I only found this one right here, and this one right here. This one on the red one is pi over 12, and this one on, I'm sorry, I did that wrong. This one is pi over 12. See that first one? And this one is pi over 6 or 2 pi over 12. So, okay, I just explained that so you understood it, but you don't have to think through it that hard every time. The whole point of that was from what I'm about to tell you. To find all of the other 6 answers, all you have to do is add the period, the new period, to all of these, and you're going to get the next answers. Watch. How do I find this next one right here? I add pi over 12 to it. I'm sorry, pi over 2 to it. How do I get this one right here? I add pi over 2 to it. How do I get this one right here? I add pi over 2 to it. Does that make sense? Because that's my period. And what's my period again? It's pi over 2, or if I put it in 12ths, Izzy, 6 pi over 12. That's why I was trying to tell you. You keep it in 12ths so that it's easier to do the math. So, ready for my next answers? Y'all ready? Let's add let's continue to add pi over 2 or 6 pi over 12 to this. What's 1 pi over 12 plus 6 pi over 12?
7 pi over 12.
You get what I'm saying?
Then it's 13.
Add another 6 pi over 12.
13 pi over 12.
13 pi over 12. Add another 6.
19 pi over
Do you see how easy that is to do? I'm just adding 6 pi over 12. And now do the same thing to this one.
It'll be 8 pi over 12, then it would be 14 pi over 12, then it'll be 20 pi over 12.
And actually, you know what? We could actually change this now that I think about it. We can change that to pi over 6. And let's just add,
3 pi over 6.
yeah, let's just add 3 pi over 6. So it's,
So 4 pi over 6, then it's going to be 7 pi over 6.
I'm adding 3 each time to the numerator, right? Got it? Now, if you added it again, you'd be at 13 pi over 6, which is what?
Too much.
13 pi over 6 is bigger than 2 pi. So you don't have to add it again.
I'm just a little bit confused. So pretty much.
And then you could reduce these when you're done. Like 4 pi over 6 becomes 2 pi over 6.
I'm sorry. I just had I got for the period, I got 24 pi over 12. But then that would turn into pi over 2, right? Or
24 pi over 12 is just 2 pi. So you just did that wrong.
Okay,
You just did it wrong. The period is just, see, this is your b here. Remember how in graphing it's 2 pi divided by b.
Oh,
So
shoot.
2 pi, here's 2 pi divided by b, which just reduces to pi over 2.
Oh, okay.
Okay.
And then
Makes sense, Brady?
You just add the period on. Okay.
Micah likes that, don't you? That's easy now. Piece of cake now.
It's so much easier.
No, it's so much easier now. It's so much easier.
Because the other way that teachers teach it is just, it really is just really confusing. Yeah.
Sir, we're heading out. Have a
All right, man.
splendid day.
Yeah.
You got it for today, let me tell you.
They do call me the math god on YouTube.
They do.
No, I'm just kidding.
No.
I didn't really write the curriculum, but I wrote a lot of things they still use, like with trig stuff. I did a lot of the unit circles that you have. They still use the ones that I created like 20 years ago.
Really?
Yeah.
So you're the math guy, who knows?
We'll see. Which number? Yeah, see you guys. Good to meet you. Which number you want? Micah, which one? Yeah, good to meet you guys. 3?
Yeah.
Oh, it's up there. Good. So number 3, we're going to first add 2
Yeah.
and divide by root 3.
Yeah.
Okay, now here's the trick. Now flip the secant. If you flip the secant, what do you get?
1 over.
Flip both cosine. So if you flip both sides, you're going to get cosine, right?
You flip the
Yep. And then just flip that. That's all you got to do.
this way.
Nope. But now what can you do to solve it?
Well, cosine root
Where does the cosine equal root 3 over 2?
that's the x value.
Pi over 6.
Oh, pi over
5 pi over 6.
Hold on. It's only positive root 3 over 2.
Pi over 6 and 11 pi.
Let's go.
Yeah.
wait, what is quadrant 4? It's a net positive.
Positive, negative. Yeah. Let's think cosine is your x. And where is the x positive? To the right, which is 1 and 4. That's all you have to think about. I just hurt my shoulder. I got a messed up shoulder. Little movements like that. Not good. All right, we got more.
Oh no, that was on Chase's.
Oh, so he filled out before he even got his answer to his question.
Yeah, but I got stuck doing it too, so it was nice to see.
Izzy, you have another question?
Yeah.
You got some more?
Let's just.
Brady, do you have any questions?
I mean, I have one that's like not related to this stuff, but like,
No, that's fine. Yeah, whatever ones you have.
can I just like show you the problem?
Yeah, just tell me and I'll write it in there.
Alright, it's tangent squared beta,
Tangent squared beta.
or yeah, you can do like
B?
X,
Okay.
minus tangent squared beta, that, so it's tangent squared beta times sine squared beta, so it's,
So it's not this.
no, sorry, it's, here, you want me to just show you?
Yeah, just show me.
Thank you, Mr. Dwyer.
Are you out of here?
Yes, sir.
All right, see you, Mike.
Have a good one.
You too.
This one here.
Oh, got it. Times. Got it. This is on day 2 homework.
You guys practice outside too? Sucks. Weather.
Oh, you said theta. I thought you said beta.
Oh, sorry.
I was wondering, like, what happened to beta? I haven't heard them use beta. Okay. And they want us to, verify. So this, they want us to verify the identity. Which kind of seems weird because like if I just factor out,
So like prove it.
prove
For some
it.
reason, my teacher did like this long, like, way to verify it. And I tried to show mine to hers. It was like a 2-step thing, and she's like, "No, you can't do that because like you can't."
Work over the equal sign or something. So how I would do this is factor out a tangent. 1 minus sine squared theta? Do they just write it like this? Does your teacher do that? Write on both sides or what? Is that okay if I do that?
Yeah.
Is that okay?
Just write it on one side, but it doesn't matter.
Okay, so I actually prefer to do it that way too.
Okay.
So I'm gonna do it her way. So what I do is I write the answer that I want at the bottom, sine squared theta, and then I just work on one side. So I'm gonna factor out a tangent squared. Now, doesn't this look familiar to you guys? Doesn't this look like maybe it's something we can use?
Cosine squared.
Yeah, that's cosine squared. So that's tan squared theta times cosine squared theta. And what's the tangent? Isn't tangent sine squared over sine?
Yeah.
Sine squared over cosine squared? And now what happens?
Cancel out.
It was pretty simple. Is that how you did it?
I don't remember.
Because that, now what happens to the cosines?
It's canceled out.
Yeah, you just get sine squared theta. That's it. Does you got another question?
Yeah, it's
17?
that way.
Left? The other way?
She's on page 6.
Oh, you're on 15.
Oh, 15. I can't count.
Okay, so now this is another one they want from negative pi to pi. Okay, so to solve this one, you're gonna have to put them, set it equal to 0, right?
Wait, I didn't mean to do this.
Is it cotangent 2x or just cotangent? Okay, I was gonna say that looks a little trickier. Cotangent x equals 0. See what I did there? Got it? Now what? Remember, whenever you're solving it, you have to set equal to 0, so you could do what? Factor, preferably. Almost always in this you do. -1, got it? We get how I did that?
Yeah.
See how I did that? Is he good? Okay, now I'm gonna set each equal to 0, right? Good. Now I'm gonna set that equal to 1, or solve it, and now I can take the square root. So the sine x equals plus or minus 1, right? The square root, remember, it's gotta be plus or minus. Remember that? Always use the plus or minus. Whenever you take a square root, you have to consider the positive and the negative square roots. Good? So if the cotangent equals 0, that means the cosine over the sine equals 0. And what's the only way you can get cosine over sine equals 0? Which one has to be 0? Yeah, see, because that's what the cotangent is, right? It's the only way that cosine over sine, which one would have to be 0? Well, could this ever be 0 in the denominator?
No,
You can't have that. So the numerator has to be, so really all this means is that the cosine has to be 0. So this happens at where? Well, now you gotta be careful because now you gotta look at what the domain is. They want it from negative pi to positive pi, not including.
Isn't it up here? 0, like with 0 in the other.
So the cosine equals, remember, this is gonna be 1, 0, and this is 0, 1, and this is -1, 0, and this is 0, -1. But remember, they only want it from negative pi to positive pi. So they don't want you to write the answers on your typical unit circle in the third and fourth quadrant. They want you to write the answers negative pi, positive pi, but neither of these are included because of see how the brackets are open brackets, parentheses? So you can't include either one of those if that's your answer. But you can include these, but this wouldn't be called 3 pi over 2. This would be called negative pi over 2. Got it? And this would be called still 0. And this would be called positive pi over 2. And like if this was an answer, it would be called negative pi over 4, for example. Not 7 pi over 4. Got it? So what are my answers? Where's the sign plus or minus 1? Here and here. And where's the cosine 0? Also there and there, right? So it's kind of redundant, but what do I write?
pi over 2.
Negative pi over 2, not 3 pi over 2. That's what some people are going to do and get it wrong, because they're going to look at their unit circle and forget to look at the domain. Make sense?
So you're only using those.
Just make sure that you're writing it in terms of what they're asking you for. Make sure that you're writing your answer in the correct way. Like, look at what the domain is. Didn't we just do this one? Or did we do one just like it? Was it this exact one? Because it looks really familiar. Root 3 over 2.
Yeah, I just added X. That was the one that I still have empty that I'm not 100%.
Yeah, we did that.
Yep.
That's the page. Okay.
Sweet.
Anyone
Yeah,
else?
nothing else.
You have more you have? You good?
That's the only one I had, but
That's
I
all we
can do
got.
one more.
Yeah, sure.
It's like the same.
is your profile photo the Michelin guy?
Yes. No, it's famous. It's big wheels.
It
It looks like the Michelin guy from here.
is like the Michelin guy.
So I'm not going crazy.
If you have another question, you have one. You good?
I got nothing else.
All right. Ooh, this is nice. Tan 3x equals square root of 3, and you're solving it between 0 and pi. So I'm going to use the u thing again, okay? So the tangent of u, if I told you the tangent of u equals the square root of 3, what would your answers be?
Oh, that would be
Yes.
oh, that would be pi over 3.
It's good to have this memorized, but I'm going to look at my unit circle just to make sure. Yeah, it's pi. It's the green in this thing. It's pi over 3 and 4 pi over 3. It's the first and third quadrant. Got it? Pi over 3 and 4 pi over 3. Now, to be safe, let's write both of them down. Okay? So it's pi over 3 and 4 pi over 3. But remember, we're not solving for u. We're solving for x, for x. So plug in, what was u again? No, u was 3x. Oh, look at what I did there. Yeah. So I should have written, let u equal 3x. Got it? So I'm plugging this back in. Got it, everybody? And now I'm dividing by 3. So x equals pi over 9 or x equals 4 pi over 9. But what was the period? Remember, when it's a tangent, it's not 2 pi over b, right? It's just pi over b. Remember that? So the period equals pi over 3, which is the same as 3 pi over 9. I want to write it in ninths. Got it? So what I'm going to do is take this period and add that as many times as I need to get all the answers that I'm going to have. So if I add 3 pi one time, what do I get? I'm adding it to this one. First I'm going to get 4 pi over 9, which is what I already have, right? So I actually didn't have to write this because I'm going to get it. But I was just showing you kind of to be careful. And then just keep adding 3 pi again.
Until you're not over 18 pi over 9.
10 pi over 9, then what?
13, 16.
13 pi over 9, 16 pi over 9. Do I write the next one?
Because it's over 18 pi over 9.
Because
Oh, yeah.
19 pi over 9 is bigger than 18 pi over 9, which is 2 pi.
So you can't go over 18.
Well, they don't want me to go over 18. They want me to only go to 2 pi.
They give you a restriction or else then you can go to infinity.
18 over 9 is like.
2. 18 over 9 is 2. So you basically just keep adding it until you get over where the domain was. Does that make sense? So that's the easiest way to do it. Find your first answer and then find your period and just keep adding it. Or find your first two answers sometimes, right? If it's a sine or cosine problem, you find your first two answers. If it's a tangent or a cotangent problem, typically you only have to find your first one answer because the period is only pi typically. And then when you add it, you'll see how I got to that. See how when I added it, I got to the 4 pi over 9. So I really didn't even have to write that one down technically.
So all these are your answers?
So those are all your answers. How many answers would you expect there to be? 6, because it's 3 times. Normally there would be 2 answers, but because of the period, because of that 3 there, you would have 3 times as many answers because your period is a third shorter. So remember that thing I showed you before, that picture? That's really what's happening.
Did you also kind of try over that?
Yep, that's your first answer. So there's your 6 answers, okay?
I got nothing else.
Awesome.
I actually got one.
Yeah.
It's 2 cosine squared x is equal to -3 sine x.
Okay, so this is gonna be, we may have done this one before already.
X 0 to
Okay, so you're gonna move it over, right? Set it equals 0, but now you have to convert one of these to the other thing. And which one's easiest to convert, a sine x or a cosine squared x? Which one's, you remember how the Pythagorean identity? So sine squared, watch this, sine squared, you only have to memorize this one formula. Sine squared plus cosine squared equals 1, and then just move it over, subtract it, and there's your formula. I just subtracted, right? I just moved it over. You could also do the cotangents and the cosecants and everything by taking this and dividing it by sine squared. You ever seen that trick? Or dividing everything by cosine squared, and it'll come up with the other one. So you don't have to really memorize those other formulas. Just memorize this one and then use it to make whatever formulas you need. So this equals 1 minus sine squared x. And now I can distribute that negative or that 2 in. Got it? And now I'm gonna multiply everything by -1 just because it'll look better. So when I multiply by -1 and also put them in the right order, that's gonna be sine squared x minus 3 sine x minus 2 equals 0. Get that?
Wait, what'd you do in that step?
I multiplied by a -1 because I want this to be positive.
Oh.
And then, or you can think of moving all of them to the other side if you want. But I'm basically, and then changing the order so that it's easier to see. Now, some teachers do this, some don't, but I like to do it. I'm gonna let u equal the sine of x, and I'm gonna rewrite this in terms of u. Do you see how I did that?
Oh,
Just because it's easier to see how you factor that. So that's gonna be 2u and u, and +1 and -2. Which means u equals -1/2 or u equals 2. Now put the sign back in, which means sine equals -1/2 sine x or sine x equals 2. That can't happen because you can't have a sine bigger than 1 because the sine is the opposite over hypotenuse and the opposite is always smaller or equal to the hypotenuse. And then this one is just going to be wherever the sine, which is the y, it's in the 3rd and 4th quadrants, and where the sine is -1, which is 7 pi over 6, 11 pi over 6.
Yeah, sounds right.
All right, that's all she wrote. Good, everybody? All right. Hopefully we're still going on Zoom.